Incredibly early, but hey, at least this means I don't have to come on first. So there is a vague hope of you all being awake. My name is Barry Dorrans. I own security for all of .NET, not by choice, unfortunately. It's just sort of, my security stance has evolved. It used to be ASP.NET, and then we had our little core stuff, and it was ASP.NET Core, and then we had a reorg, and suddenly it's all landed in my lap. So today I'm going to take you through the changes that we have made in ASP.NET Core to security, and there are quite a few because, you know, not being content with upsetting you enough of all the things that we've dropped in ASP.NET Core, we thought we'd change some things that you thought you were used to. So this will be a specific security talk because I am sure in Ms. Appel's talk, which comes up next in another room, she's going to ignore security altogether. Yep. Your talk, Rachel, your talk says that it's what you need to know. Didn't security come into that?
No, because you're going to tell them what you need to know about that.
All right, fair enough. That's very kind of you and probably not accurate. So, this is what I want to try and cover. Today, we are going to go through what has changed in authentication. I'm going to talk a little bit about what we've done with data protection and how we've thrown away machine key and how that is both good and bad. Then I'm going to talk about how we have changed authorization, which is completely because we like doing that to you. And then I'm going to go through some miscellaneous changes that we've made because they seemed like a good idea at the time. Part of the joy of ASP.NET Core is we have been able to throw away an awful lot of back compatibility garbage, and I have been able to throw away an awful lot of things that we kept even though they were insecure, which has made me incredibly happy and hopefully reduces the number of MSRC cases I see every year because every time I get one of those, my hair goes ever more gray. So, authentication. Authentication is basically saying who the user is. And we have a bunch of options in our templates. We have no authentication whatsoever. Your website is anonymous. You don't need anyone to log in. You do not care. We have individual user accounts, which used to start off in ASP.NET 1 as the old-style membership providers, and then as we move forward with MVC, it turned into Identity 1.0, then turned into Identity 2.0, and now we have Identity 3.0, or Identity Core. I don't think we ever made up our mind. The two things are interchangeable. We have work and school accounts. That is Azure Active Directory, because you can get that for your school as well. And we have Windows authentication for those of you that are still writing intranet apps that run on-premise and your users cannot cope with the difficulty of typing their password a second time. In addition, we also have a bunch of social authentication pieces. Now, in the templates, these are wired up so they hook into individual accounts. So a user can create an account and then attach a Facebook account to it or a Twitter account to it so they never ever have to remember their password ever again. But you can use them as first-party identity providers if you just want people to log in with Twitter or you want people to log in with Facebook and so on. So out of the box, we will give you Facebook, Twitter, Google, Microsoft account, and OAuth 2. There is a community-driven project, you can see the URL there, that adds the most bizarre things that I have never heard of. Obviously, I've heard of GitHub and Dropbox and LinkedIn and everything else, but there's support for social networks that are only available in Brazil or in Russia or in China. But because these things all talk OAuth 2, basically the community project is just a wrapper around our OAuth implementation that points you to the right places so you don't have to think as much. All you have to do is plug in your secrets, and that's it. So individual user accounts are held in a local database, or if you're in the cloud, nothing's local, so you just stick them in SQL Azure or any of the other popular databases that are floating around. It uses EF, so if your database has an EF provider, you can use it. We allow you to customize a little bit. We allow you to customize the way the user object works, the way roles work, and so on and so forth. But we're quite opinionated. We're not going to allow you to configure how we hash and secure passwords too much because we believe we're doing the right thing. And so we're taking that choice away from you. None of this has really changed from Identity 1.0 to Identity 2.0 to Identity 3.0, except for the schema, because we like to see you run those EF migration scripts that then collapse, and then you're like, oh dear, what sort of state is my database in? We have work and school accounts. Like I said, they are backed by Azure Active Directory, and it uses OpenID Connect. It does not use OAuth, but we hide all that from you. Some of you at this point, if you have put some applications in the cloud before, but have not moved your internal AD up to Azure Active Directory, you have been used to federating to a local instance of ADFS. ADFS takes your internal AD and allows people to log into it in a secure manner and then sends information to an application. ADFS right now does not talk OpenID Connect unless you want to install an ADFS 2016 beta. And if your networking people see that request, they will go white with horror because putting beta code into something to control your AD is a little bit of an unknown quantity. However, if you can't persuade your network people to upgrade your ADFS infrastructure to a beta, then you can configure existing versions of ADFS to expose OAuth 2 endpoints. And then you can use the OAuth 2 support that we have to talk to the current supported versions of ADFS. Actually, that's unfair. Betas are supported. And finally, we have Windows. Oh, if you have been stuck using SAML and WSFed, they are dead. They're so old, and no one loves them anymore, and they're not cool and trendy, and they don't have JSON, and they don't have JOT, and they don't have the curly brackets. Instead, it's XML, and everyone hates XML now. So they're not supported. We will get there eventually, I hope, but we have to bring a whole bunch more classes into .NET Core. And then we have Windows Authentication. Windows Authentication needs IIS. If you have looked at ASP.NET Core, you will see that we have our own web server now. And that web server hides behind IIS, or if you're on Linux, it hides behind Nginx because exposing it directly is not a good idea. Not yet, anyway. Eventually, I will be satisfied with it, and they'll get a great big stamp of approval. And we'll say, sure, throw this onto the internet and let everyone have at it. But right now, we recommend that you put it behind IIS or you put it behind Nginx, some sort of forwarding proxy. So if you want Windows Authentication, you have no choice but to use IIS because there is no support for Windows Authentication in Nginx, because who wants to support Windows Authentication on Linux? It's kind of weird. You will need to have local domain joined servers if you want to authenticate to your domain, and we do not do impersonation anymore. Impersonation is when a user logs in and their requests then switch security contexts to run as that user. It was never particularly scalable. It was a bit of a security nightmare. Things could go horribly wrong, and we have taken that away from you. When you want to use impersonation, you can get the user from the current request, cast it to a Windows identity, and call impersonate around the tiny bit of code you need to impersonate, which is generally talking to a database. Don't do it for the entire request. Do it for as small a scope as possible. And then don't forget to unimpersonate afterwards. Those of you that have made an investment on custom identity classes and custom principal classes, you're going to hate us because we've thrown that away. Everything in ASP.NET Core is a claims principal and a claims identity. Those of you that looked at the Katana pieces will be aware of the concept of middleware. Everything is middleware now. You can also have multiple instances of authenticating middleware. So you could have cookie authentication, which is what the Forms login uses, and then you could have JOT bearer authentication at the same time, and it figures it out for you. You kind of have to choose one to run automatically, which is it will always run on every request, but you can pick and choose the identities that come from individual middlewares when you are authorizing, and we'll come on to that in a little bit. If you configure more than one middleware to run automatically, the polite way to say this is the behavior is undefined. All hell breaks loose. Don't do that. Cookie middleware, because generally it's the right thing to do, we have configured that so it's automatic. Everything else is not automatic. And finally, which was a huge bugbear for a lot of people, cookie authentication now understands the differences between 401 and 403, between unauthenticated and forbidden, and it can return the right status codes. It always used to return 401, which was a real pain in the backside when you were writing SPA apps or you were calling AJAX bits and pieces, and you would get lied to be perfectly honest. So we actually now finally understand the difference between unauthenticated, user hasn't logged in, and forbidden. User has logged in, we know who they are, and they don't have permissions to do what they want to do. We've also taken the cookie middleware and made it so you can use it on its own. So if you don't like our opinionated identity stuff, and you want to write your own login, you want to write your own 2FA, that's absolutely fine. The fun part comes when, well, how am I going to persist this? So we have made the cookie authentication usable in code without having to rely on identity. So you don't have to think about the encryption and the signing. You don't have to think about how you're going to serialize things. We will do it all for you. All you do is hand us a user principal. We will encrypt that user principal, we will sign that user principal, and we will dump it in a cookie. Now, if we're encrypting it, that means there has to be encryption keys somewhere. And the encryption keys are coming from our new data protection stack, which is the next section. But that means that these encryption keys must be synced between servers, just like you had to set machine key in web.config to be the same absolutely everywhere, except it's not in config files anymore. And we can use the cookie middleware to serialize your own claims identity. It splits everything up, it signs it, and it validates it when it comes back in, and will rehydrate the current user. So, configuration. You're pretty much always going to have to do this if you're going to use cookies, unless you use our identity stuff, which does this for you. Those of you that have been looking at ASP.NET Core will be familiar with our new way of configuring things. But you can see that we have an authentication scheme, which is basically the name of the middleware that we're going to give it, because you can have multiple cookie middlewares if you really want. You could have cookie 1 and cookie 2. So they all must have unique names. You have a login path, which is where the user logs in. You have an access denied path, because like I said, we now finally can tell the difference. You have automatic authentication, which is the thing I was saying you don't want to put on more than one middleware. So that means that cookie middleware will always run with every single request. It will look for a cookie, it will validate it if it finds it, and it will rehydrate the user. And then you have automatic challenge. What that does is when a user is unauthorized or a user is forbidden, it will redirect them to a login page or an error page. You can turn that off, which is what an awful lot of people want to do when you're in AJAX scenarios. And then in your login page, you just call HTTP context authentication sign in async, because everything is async now. You're going to pass in the name of the cookie middleware that you wired up in startup, and then you're going to pass in the current user principal that you want to persist to cookies. And to sign out, you call sign out async, again passing in the name that you have previously configured. If you are going to do this, I would strongly recommend that you create a static class somewhere that then has a static string in it that is your cookie middleware name. Because when you cut and paste those things everywhere, you are going to fat finger it and wonder why something doesn't work. Which is probably what I'll end up doing when I'm trying to do a demo. If you're doing it yourself, there are a few things to be aware of. Once a cookie is dropped, that's it. that is where your user comes from. So if I have logged in as Barry, and there is a cookie that has been dropped that says I am Barry, and an administrator goes into the database and disables Barry, it doesn't matter, because the cookie is your sole source of truth unless you do something else. There is a validator, and validators will run on every request. And inside that validator, you can go off to your database and say, is this username still live? Or has this user's roles changed? Has this user's claims changed? Because I really want people to move away from roles and move to claims because they're cool and trendy, and it's what Jot talks. So we use this within identity because we use it to sign users out if they choose log out everywhere. We use it in identity if your roles have changed. So we can rehydrate the roles on the current user in the cookie. And that runs about once every 15 minutes. Validators are expensive. Like I said, they'll run on every request. So you need to put in your own caching or throttling logic according to your own business rules. So, like I said, we can have lots of authentication middleware, and they all have this thing that configures the same. So this time I've got my automatic authenticate for bearer to be false, and we're going to show that in a minute. And then implementing a validator kind of looks like this. You create a static method somewhere called validate async with that signature, and there are two things that you can do. If a user's details has changed, but they're still valid, if refresh is needed, you can call context.replace principal. And now call context should renew and set it to true. If validation has failed, call context.reject principal, and then sign them out. And we're done. And then you wire it up on the cookie authentication events. There are lots of things underneath the cookie authentication events that you can hook into. But as we're talking validators, here we go, on validate principal. And we're done. So I'm now going to swap to Visual Studio and pretend that I'm still a developer and not a PM anymore. So here we have, come on, mousy, mousy. There we go. The demo code for all this will go up into GitHub in about an hour when I get back to my desk. And the slides will be available as well. So we are adding authentication down here. Fudge. OK, let's just... I told it to dupe the screens. There we go. OK. Thank you, PowerPoint. So I'm going to wire up cookie authentication. As we've seen, I've got a validator. And what I am going to do is inside my account controller, I'm cheating. I'm dropping my cookies. Well, I'm creating a user principal. And I'm creating a claims identity. And then I'm going to drop it, and it should work. Now, one thing to note, because this bites people when they start trying to do this manually, is this parameter. There are two ways to create a claims identity. A parameterless constructor and a constructor with a parameter. You always want to use the one with the parameter, because if you create one without a parameter, what you end up with is a user identity where the isAuthenticated property on it will return false. So nothing works because all our systems check that first, and it's like, oh, that user's not being authenticated. You may consider this a little bit weird. I would kind of agree with you, but we do use it for things like Facebook auth, where you're hopping to Facebook, then you're coming back. You're not actually authenticated at that point. We have to go to a database, check that you're already registered, and flow it through. So if I hit run, it's going to be a very, very exciting demo. You will see my stunning web design skills. Which are not very good. Don't get excited. Dumpty 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 dum. There we go. So, hello world. So I'm going to hit that. It's gone to my login screen. I'm going to make up a username. You will note that there is no password. Please don't ever do this. I don't think I should need to say that. I'm going to hit login. And lo and behold, it says I'm authenticated because I have dropped the cookie using cookie middleware, and it has come back again automatically on every request. And to prove that we know the difference between unauthenticated and forbidden, I have a quick authorization page which will fail for everyone. And if I click fail, it goes to my forbidden page, which has been a user request for years. You can do all sorts of funky things with forbidden pages. You could actually prompt the user to log in again. Or if you're my bank allows me to log in and see the balance of my account. But when I want to do things like transfer money, it requires that I re-authenticate. So you could put a second set of authentication rules in here to prompt again, or to prompt for a stronger authentication, like you're about to delete a user from your database, therefore I need you to log in with a smart card. It can all go in here. Then you just stick an extra claim in the identity, and that's the claim that you would check for in the authentication rules. And we will come on to how to do authentication in a bit. So is that clear? It's incredibly simple. I mean, here is your sign-in code. That's it. The hard part here is just creating the identity and remembering to put the parameter on claim's identity. So are we all good with that? Yes? Are we all awake? Okay, fair enough. It's coming up to 10 o'clock now. You've probably had more coffee than I have, so there should really be no excuse. Okay. Let's see if this goes back to where it was. Yay! And let's try duplicating again. There we go. So there are ways to limit by the authentication scheme. If you remember, I said you have to give every middleware an authentication scheme name. One of the things that people got annoyed with us about when they were trying to write single-page applications was the fact that cookie authentication would always flow, because that's how cookies work. And you wanted to switch to bearer authentication because it's cool and trendy and it does not have any CSRF vulnerabilities. But what would happen was you'd end up with a principal with two identities, or things would go horribly wrong. So now, when you are authorizing, you can choose which of the middlewares run, and then you only get the identity that has been produced by that middleware. So if I send both a cookie and a bearer token, and I use that line above, I will only see the user that has come through with the bearer token. If any of you actually hit this problem, no one's writing single-page applications? You've hit that problem.
I haven't hit that problem.
But you haven't hit the, oh, all right, fair enough. Are you doing the login with the SPA thing itself rather than bouncing to the cookie pieces and coming back again? Yeah, which is generally the nicer way to do it. But some people want to have all their APIs in one place, and this was a huge user ask. So I have yet another stunning demo. Let's see if I can swap. Look at that. We'll set this as the startup project. This isn't the exciting bit. The exciting bit is when we got onto authorization, because that was my feature, and I was very happy to get it rewritten. But people have been demanding this. So here we go. I'm going to log in with a cookie. I'm going to call myself Cookie so we know who it is. I'm going to hit login. And then this is the bearer token. I'm going to type in bearer. And what the bearer token will do is the Ajax behind all of this, the JavaScript behind it, will put it in an authorization header. So you have 2 bits of authenticated information. Don't ask me why they called it authorization in the HTTP spec. It is not. It is authentication at that point. It's up there with misspelling referrer, which was very good. So if I hit who am I, what this is doing is going to go to an Ajax endpoint, and it's going to look at the identities that it has received and it just prints them out. So you can see I've got two, because my cookie is flowing, and also I have my authorization header, which just has bearer in it. And if I click Who Am I, where I have restricted things to the authentication scheme, I am only getting the bearer identity, which, like I say, is important for some and important for a bunch of SPA apps. And also, if you want to use your API endpoints from both a website and from a first-party mobile app or a third-party mobile app, this enables you to be picky about what rules you are accepting. So, honestly, authentication has not changed that much, apart from the fact that we now finally can tell the difference between a 401 and a 403, and finally you can limit based on where the authentication information is coming from. So I said that we were going to encrypt and sign your cookie for you, and that means we have encryption keys, and we have to store them somewhere. We threw away machine key, because machine key was a dumb idea. Machine key did not have any way to easily rotate it and keep information that was previously encrypted with it available. Any of you that have had to try and load balance machines, or running in web farm environments, or running in the cloud, I will apologize for machine key now, because once you set it, you could never reset it, because half your machines would go wonky. You would have to sit there with a script and press a button and hope they all synchronize within a couple of milliseconds of each other, because everything was going to fall apart. And the other problem is that, you set an encryption key should be rotated, and that's hard. So we've thrown away machine key, but like machine key, it is aimed at ephemeral data that you don't care about using. Now, I know some of us have not been very good at reading the documentation. The complaints that we've had when people have changed their machine key and they've persisted data into a database somewhere and it no longer works, and we point at the documentation and say, we told you it's for ephemeral data, you shouldn't care. And they're like, yeah, but we've stored tax returns and stuff. Okay, so I will underscore this. It is aimed at ephemeral data. However, if you want to use it for things that aren't ephemeral because you don't want to write your own encryption code, and that's probably a good idea, then if you persist your keys properly, it should be fine. We don't give you a lot of options in data protection. It's extremely opinionated. We will encrypt and sign for you. You have no choice. You do not have the ability to say, just sign this for me. We are encrypting and signing it. We are choosing the algorithms, mostly, except if you're in Russia. For people who are going to deploy code in Russia, we have extension points where you can start using Russia's very own cryptographic algorithms, because that's a great idea. Well, it's a legal requirement, but there's not a lot you can do. We will rotate keys automatically for you. We will create new ones once every 3 months by default. We will isolate your applications automatically, so you can share the key ring between multiple applications, and application 1 will not be able to decrypt information from application 2. We give you isolation within applications by deriving subkeys based on a purpose. So you could have a data encryptor that encrypts user information, and you could have a data encryptor that encrypts order information. And the user encryptor cannot decrypt information from the order encryptor. So we provide you isolation at that layer. And we will attempt to figure out where to store your keys based on the application platform. But you can write your own, and you probably will want to write your own as you move along. And it's incredibly easy to write your own. There are 2 methods that you should implement, only 2. One that says, write a new key to the key ring, and the other one that says, give me the entire contents of the key ring. And like I said, we will allow you to plug in CNG algorithms, which is basically there to support Russia, and maybe if China keeps going the way it's going, China eventually. So, for those of you that care about the details, we generate a 512-bit master key. We roll it every 90 days. We derive keys every single time. So if you try and protect the same data twice, you may end up getting different results, but that's perfectly valid. We call AES 256 CBC for encryption, and then we HMAC SHA-256 over the top of it for authenticity, which means it cannot be changed without us detecting it, which is kind of important. We provide you some key stores out of the box. If you're running in Azure web applications, they have a special folder that will get synchronized between all the instances of your Azure web application, and we put the keys in there. The one thing it doesn't do is synchronize across slots. So if you are using slots to swap from a pre-production environment to a production environment, you lose your encryption keys. I've asked them very nicely if they can give me a special folder for that. They are working on it. It will arrive eventually, but this is one of those circumstances where you may want to write your own key store. If you're running an IIS with no user profile, which is the default, we shove it all in the registry. Then we limit it, or we encrypt it using DPAPI, good old Windows, and it's then ACLed to the current worker process. There is a PowerShell script that you must run to enable this, and that is on our wonderful documentation site, because this bit is actually really well documented. There's about 50 pages on data protection alone, talking about what we do, down to hex dumps of what we're outputting and telling you what every single byte is. If you're an IIS with a user profile, which is IIS Express, or you're using it from the command line, you're using it with the console app, we will stick it in your user app data folder, and we will protect it with DPAPI again, except it's user-based DPAPI. It's limited to the current user rather than being system-wide. Finally, if we don't know what to do, we'll put everything in memory and we'll throw them away, because we're like that. We're carefree. We will throw away your encryption keys when your app stops, which is why I say it's for ephemeral data only. But you can write your own key stores. We have just finished one for Azure Blob Storage, and that's now up on GitHub. I don't think it's in a NuGet package yet. They finished it while I was at Black Hat last week, and I haven't had a chance to look at it yet. There will be one for SQL coming soon. There's going to be one for Redis, because people want to put things in a cache that then throws them away. But I believe Redis does persistence now, which means it's not just a cache anymore, but whatever. And you can write your own. Stick them in a SQL database. It's just a single column. In fact, it's XML. That's what we're outputting. And so we are protecting it DPAPI, DPAPI-NG if you're in an Active Directory environment, so the encryption keys will actually synchronize via Active Directory. You can use an X509 certificate if you are targeting the .NET desktop. If you're not targeting the .NET desktop, then that is not available because they haven't given me those classes yet. So we fall back to plain text. So you can use this in, like, well, 2 lines of code, maybe 3. If you're doing it manually, you create an instance of an iData protection provider. There is only one. And then you create a data protector from it. If you're in ASP.NET Core, you just call app.useDataProtection, and then inside your controllers or anything that's registered in DI, you can take an instance of iData Protection Provider, and then you store it and use it. And you call protector.protect to protect things, and protector.unprotect to unprotect things. The only parameter you give us is what you want to protect, and that's it. You don't get any more options than that. So there you go. There is 1, 2, 3, 4, 5, 6, 7, 8. 8 lines of code, half of which is basically telling you what to do, and it shows you how you can use it and not use it. You can see in Create Protector, we actually take a purpose, which is what I was talking about earlier, where you can have isolation within your own application. So you would have, you know, a different purpose for storing user data and a different purpose for storing order data. And never the two shall meet. So the way purpose works is we are deriving keys. You shouldn't use user input as your sole source of what a purpose string could be, because then, of course, a bad user can put in a purpose for somewhere else in your application and start decrypting that information, and that's not good. So generally, we say you should use the namespace, class, and then a version number. So we have configuration points for the key stores. We have configuration points for how you're going to expire keys, and then we have this one thing where you can plug in a new encryption algorithm if you're in Russia. And apps are isolated by default, but you can share key rings by setting an application name. So if you have two apps and you want to share the data and share the key ring and see each other's keys, you just set the application name for data protection to be the same. And we have a forward compatibility for .NET 5, 4.5.2. People ask us about backwards compatibility. No, we're not doing that. What we are doing is we are dragging 4.5.2, kicking and screaming into the .NET Core world, and we are replacing machine key.protect and machine key.unprotect with the new stuff. Or you can just call the protectors manually. So you could have your older apps sharing a key store with your core apps and being able to protect and unprotect data, and also actually get access to the membership cookies that Core would create. So here is our good old configuration. This should now be quite familiar to everyone. In this instance, we are going to persist the keys to the file system, because if you're in an AD environment, why the heck not? Just have a file share, shove your encryption keys on there. That's a great idea. We are going to protect the keys with a certificate, which now actually makes a file share a great idea, because hopefully that certificate is only available on servers that need access to it. And we're going to set a fixed application name, so we can share things between instances, we can share things between multiple applications. When you want to write your own, and you will, when you want to store things in SQL, you want to store things in Mongo or wherever you want, you just need to implement an IXML repository and configure it. And like I said, there are only two methods, and they are incredibly simple. Get all elements and store element. That's it. When you store an element, it's, well, we're going to give you a representation of a key, and you just need to shove it somewhere. We don't care, as long as you don't change it. And then get all elements is called when the data protection layer starts, and when it encounters a piece of data that it doesn't have a key for. Because we tested out key rotation because it's automatically, and what we did was I got one of our per developers to spin up 50 VMs at once, point them all to the same file share, and then set the key to rotate once a minute just to see what happens. And it worked. And I was surprised, I have to admit. It scales, it works really well, because what happens is it's not one great big file or one great big blob. What happens is we're creating individual files for individual keys. So there's no locking. So if you implement your store like that, so you have individual rows for each key, there is no locking at all. And finally, we come on to the part that we have changed the most. How many of you have written your own authorize attribute? Sorry. That was painful. More often than not, it went wrong. So we're not doing that anymore. There is an authorize attribute. It has absolutely no code behind it. Feel free to inherit from it. We're not going to call anything. It's just a marker. We have completely overhauled authorization. So you can now express your rules in code without having to write custom attributes. It's all based in DI. We can call through for resource-based authorization. You don't have to copy code from one place to another. Like I said, we already had the scheme filtering, and then we have custom policy providers. I have written an entire workshop on this that takes about an hour and a half to go through, that starts from just using the authorize attribute, and then takes you through roles, and then gradually, ooh, goodness me, that's going to look great in the playback. It takes you through roles, and eventually we get through to policies and multiple policies for requirements and so on and so forth. I would strongly recommend that you go through the workshop. I've even had our interns go through the workshop to make sure I haven't forgotten anything. So it's easy to follow. If something is missing, by all means, create an issue on that repo, and I will address it as soon as possible. So, authorization now has changed. And what we have is a requirement. And a requirement is expressed by implementing an authorization requirement on a class. It doesn't have to do anything, but you can parameterize it if you want. So I'm going to give you a real world example. So Microsoft Office entry, the shiny badges. There are a few ways to get into Microsoft Offices legally. Let's just say legally. I don't want anyone expecting me to implement a break a window requirement. So we're going to talk about an Office entry requirement. So the way most of us get in the morning is we tap our badge against the card reader. The card reader checks that our badge is still valid and that we haven't been fired, and it lets us into the building. And then there are those mornings where you've had a heavy night of drinking the night before and you've left your badge at home along with your wallet, so you're not going to be able to get coffee and everything is going horrible. So you walk up to reception, you say, I have forgotten my badge, and they give you a little sticky badge of shame. That is a temporary badge that's printed out in black and white. It takes the awful photograph that's on your normal badge and makes it look even worse and highly pixelated, and you stick it on your chest, and then they press a button and open the doors for you, and you spend the day being pointed at and laughed at because you have the sticky badge of shame. And then there are visitors. So you get a temporary visitor badge, and again, that has a photograph because we have cameras and we like to humiliate you, and that's never a good photograph. And you can be accompanied by someone who will then tap you into the building. So we have a requirement. I need a way to get into the office building. So I'm going to write an office entry requirement. I'm going to keep it simple. I'm not going to have things like the building number or the room number or anything like that, but you can see where this could go. You could actually have an integer property in here that is building number, and you would use that to go back to your database and check that this person is allowed to be in this building, and yes, they're allowed to go into Satya's office, which no, I'm not. So we have requirements. And then we have handlers for requirements. So I have my requirement to get into the building, and the first handler will be, I have a swipe card, or it's touch, it's not swipe anymore. So I will implement an authorization handler. It will take my requirement, and there is a single method to override, handle requirement async, because like I say, everything is async. It provides you with a context, which will get you your current user and a bunch of other stuff, and it will pass in the current requirement as well. So if you put parameters in your requirement, you'll get access to them, but in this case, I haven't. So nice and simple check here. I'm going to look to see if the user has a badge number claim. I'm going to check that the issuer is who I expect it to be, because, you know, Nintendo's down the road. Don't go down there looking for Pokemon Go. There is nothing special on the Nintendo campus, because I did that the first day and I was really disappointed. You'd think they put rares on their own campus, but no. So you want to check that the badge is from your own company. And if that's, you know, if the user has passed, they have a badge, it's from your company, you call context.succeed with the requirement that you have evaluated. And then you return. And then we take our requirements and we build a policy from them. So we are adding a named policy in configure services when we've added our authorization. We're going to add building entry, and I'm going to say the policy has this single requirement, which is office entry. We can have multiple requirements. They will all pile up, they will all be evaluated. And then I stick my handler into DI, because DI is everywhere now and it's magic. And lo and behold, you probably had got there before me. Instead of having roles, we have policy. The policy that we have just created. And like I say, create a static class, have a static string in there, and use that in your attributes. So what will happen now is when somebody hits building controller, it will evaluate the requirements on the building entry policy by calling every single registered handler for each requirement. So policies can have one or more requirements. Every single requirement in a policy must succeed for the policy to pass. And every single requirement is evaluated, even if it's something has originally or has failed further up the stack, because people like to do things like logging in requirements. So just in case you have written a requirement with a side effect, we will evaluate all of them. And don't forget to register your handlers in DI. I keep doing this, and I'm now telling myself this in the hope that when I go back to Visual Studio and try and demonstrate this, I won't do it again. I have a cheat sheet, but I always skip over that part for some other reason. If you don't register your handlers in DI, we don't know what to do with the requirement, and we just fail it. So you saw, if you have drank enough coffee, that when a handler has successfully evaluated stuff, it calls context.succeed. If it doesn't have enough information, or if it goes, no, that isn't quite right, it does absolutely nothing at all. We have context.succeed, so it seems obvious that we have context.fail. But if you remember, I said that we can have multiple handlers for a single requirement. So my has a building badge requirement succeeds if I have a building badge, but there are other ways to fulfill that requirement, which is why I don't fail. I just say, nope, I can't evaluate this, so let anything else try and evaluate it. So I could, the next requirement would look for the temporary badge, and if that succeeds, then that requirement is fulfilled. Context.fail is for horrific circumstances. My database has fallen over. There's no point in anything else running. I don't know what I'm going to do. I'm having a panic, or this user is David Fowler. I don't want to let him into the building at all, so nothing else should succeed. That's what context.fail is for. It is very rare that you will write something that needs it. So don't call it unless you really have to, like your database is on fire. You can also evaluate your policies in code. So the fun thing about writing things in custom attributes is you would probably want to try and duplicate that somewhere between declarative and imperative. And so you would either have everything out in a helper class that you could call from various places, or you'd more likely cut and paste the code and duplicate it. So because through the magic of DI and everything in ASP.NET Core is now a service, we have Authorization service. You can take an instance of that in your controller, and then lo and behold, authorize async is there. If that fails, you can return from your controller new challenge result, and we will do a 401 or a 403, an unauthorized or forbidden, based on whether a user is logged in or not. So, demo time. This is when it all starts to go horribly wrong. I know some of you are thinking it was horribly wrong for me to be here in the first place. So, we have a very simple app showing off my stunning web. Did it switch this time? Yes. Okay. So, startup.cs, I have add authentication. I'm going to use cookie authentication again. And inside my home controller this time, because I'm putting everything in one place, I'm going to create an identity that has a single claim, which is my name, and then we'll automatically log it in. So if I run this, we have our enter building, I haven't written any rules, I haven't written any policies. All I'm doing is plain old authorize. I have entered the building. So, we're going to start by writing requirements. And basically doing everything that I've just talked about. So, if you caught it all the first time around, feel free to fall asleep. New class. Enter building requirement. Let's see. As you can now see how bad I get at typing. And I am going to just make this a requirement, which we did by what? Authorization requirement. Well done, sir. That makes me feel happy. Someone was paying attention. Okay. And then it'll go, where is it? And I can pull down my little magic light bulb. And you will see that, lo and behold, it is in the authorization package, where you would expect. So that is my simple building requirement. So now I'm going to skip ahead. I'm not going to write a handler because I want to show you what happens. I'm going to write a policy around it first of all. So I'm going to go back to startup, and in my add authentication, I'm also going to call services.add authorization. And I'm going to do my magic options with the kill me arrow. I'm sure there's a technical term for that. I'm just not sure what it is. I can never remember. Options.add. Ooh, add policy. Building entry. Policy. Policy.requirements. Add new enter building requirement. Oh, look at that. So we have our building entry policy, and I am going to apply that to my building entry. Going to go over here, enter building. I'm going to call authorize policy equals building entry. So when I run this, what do you think will happen? Bear in mind, I have not implemented any handlers. It'll do something wrong. So bear in mind that I'm logging in and dropping a cookie automatically. I'm not doing this. So the user is authenticated. So authorization fails, and it drops through to my forbidden, which in this case is like, yeah, security is going to come and take you away. So we need a handler. And we're going to go back to here. And we're going to add a new class. You know what, let's just do it this way. Building entry as employee handler.cs. So we implement authorization handler, and then it will go a bit barmy because it goes, I haven't got my namespace. And then I'm going to put building entry requirement. And then I'm going to say, ooh, what do I need to implement? Which is that. Let's just put some returns in here so you can see. So in this case, I am going to cheat because it's a little bit long. So I'm going to go to my cheat sheet. And I'm going to cut and paste it in because no one wants to see me make so many typing mistakes. So what we're doing here is we're going to look for a badge number claim in the user. We're going to check it's been issued by Contoso. And if it's present, we're going to say, OK, they have a badge, and that's fine. Because handlers are in DI, they can take instances of anything else that's registered in DI. So in a more real-world scenario, we would be injecting our repository for valid badge numbers, and we would go to that repository and check that the badge is still valid. But that's just too much of a faff for a demo. So we have our handler, and I'm going to go and add the claim. Home controller, let's put that in here. So what will happen when I run this now? What have I forgotten to do? What did I say that I always forget to do, and you will forget to do, and it will then puzzle you? Well done! The handler is not currently in DI, so it doesn't know what to do with this. So let's go back to startup, and in my services, add a transient, authorization handler, because, you know, in the real world, you're going to take a database into some of these things, so it needs to be transient. You don't want to make it a singleton, because otherwise EF gets in a real hissy fit, and nobody wants that. Building entry as employee handler. There we go. So we've added a badge number claim to the user that I am creating automagically. And I'm going to look for that badge number claim in my handler. And if it's there, hopefully I get into the building. Yay! OK, so that works as expected. But we want to cope with our I have forgotten my badge scenario. So I'm going to write another handler. And this will demonstrate why we don't want to call fail. Because if I've forgotten my badge, but I have my temporary badge, I should still be allowed access. So nothing should, you know, the first handler that gets called shouldn't fail. You should only fail if it's like, you know, the building's on fire, you can't come in. So I'm going to do another one. Class. Temporary, oops, I cannot spell. So I have my temporary badge handler, and you know what? I'm gonna authorization handler. Don't do that. Oh, no, it wasn't authorization handler. That's the old one. Oh, dear. My bad. There we go. Don't need my I. Building entry as employee handler. And then I'm going to go back to my cheat sheet, because I'm sure you're all bored already and no one wants to see me type. What are you complaining about? Oh, I gave it the wrong. I give it handler and not the requirement because I'm an idiot. There we go. We should stop fussing now. So I'm going to, this will now look for a different claim. It will look for a temporary badge expiry. And we're going to do a little bit more evaluation in this code. So we're going to figure out whether the badge has expired or not, because that's really complicated code, and I can write that under pressure in demos. And if it has expired, we won't let someone in. So I'm going to go back. I'm going to take my permanent badge claim away. And then I'm going to shove another claim in here. So I've got a temporary badge claim. It's going to contain a date, and the date is like a day away. So if I run it, hopefully everything works. Enter building, this time with my temporary badge. Ooh, what went wrong? Exactly. I knew I'd forget to do it somewhere. So, back to startup. You can actually sort of cheat. If you're not going to do anything complicated, like take DI or anything in your handlers, you can actually implement both the requirement and the handler in the same class, and then it figures it out. But that's kind of unrealistic for anything but the most simple scenarios. Temporary badge, access handler. But the more detailed workshop will walk you through both that scenario and then why you want to split these things out. So, yay! So I've come in with a temporary badge, and because I'm evaluating the date, if I go back and I change the expiry to be yesterday, and run it again, then I will be forbidden. Yay! So, all that code you wrote in a custom authorize attribute, you now put in policies and handlers. Does that make sense? Is everyone actually happy with that you no longer have to write custom attributes and test them anymore? Because these things are all unit testable as well. Because testing customized authorization attributes was also painful, to say the least. So we have 15 more minutes, so we get to the miscellaneous stuff, which is all very exciting. So like I say, remember to register your handles because you've seen me forget it. And remember to check that the claims that are coming down in identities have been issued by someone that you expect, because we don't want someone with a Nintendo badge walking into Microsoft unless they can transfer me a bunch of Pikachus. We also have resource-based authorization, where we get very realistic. This was another huge request. So we're no longer just authorizing based on the current user principal. We can also pass something in. For example, SharePoint. I can model SharePoint's resource-based authorization, because when you are in a document library and you create a document in the document library, you get full permissions for that. You can, like edit the document, you can delete the document, you can add a new one in that library. But in order to check whether a user owns a document or not, you usually have to go get that document and then look at the property inside it and say, oh, yes, it's the current user. So this is what I mean by resource. Resource is always imperative. And you can also check things like, yes, it's a SharePoint library. Does the user have permissions to add? Do they have permissions to read? Do they have permissions to delete? And then you can add a second handler, so an administrator has all of those, and you don't have to worry. And it becomes a little bit more clear with code. So a resource-based handler looks pretty much like a normal handler, except it takes an extra parameter. In this case, I've called it document. And lo and behold, handle requirement async also takes document. And then you look at the current user, you look at what you want, you look at what you need to do inside the document to see who the owner is, and lo and behold, it works, and we're going to call context.succeed. This has to be called imperatively. No, we'll skip that. Because the document, the resource has to be loaded, and we can't load that at the attribute point. We can only load that once you're inside your controller or once you're inside a code that your controller is calling. So this needs to be called by injecting the authorization service in your constructor and then calling authorize async on the instance that you get. Other quick things. This is how you authorize your entire application. You apply a global policy to your entire application because everything is policies. And then you just shove it in a filter and away it goes. If you're wanting to do the limitation of the identities based on the authorization scheme, you can also do it in policy, not just in the authorize attribute. So you just call policy.authenticate schemes.add and then the scheme name that you want to add. You can also start adjusting things in views. Razor has this ability to accept DI in your Razor views. I am unconvinced that this is a good idea. I know it upsets a lot of people. Personally, I would put the things that you need inside your view model, but okay. So you can inject the authorization service into your views, or check in code behind and set flags saying, yes, they can see this or not. So you can call authorization to authorize async on policies and then hide bits and pieces of your view based upon the permissions of the current user. So if they're not an admin user, they don't see the admin link. Now, of course, you need to duplicate these checks in the controllers because hiding an item in the view is not enough to protect you because someone's just going to type /administration in the URL in their browser and see what happens. So you need to duplicate these things, as our per intern found when I security reviewed her code. It was very sweet. She had put authorization in the view, she had hidden things, but in the post action, there were no authorization rules at all. So it's like, okay, so Crystal, hit F12, now change that URL, and now hit submit and see what happens. She was a little bit worried at that point. So remember, you have to duplicate these things. And if none of this is enough for you, because I know a bunch of you would like to put parameters on the authorize attribute rather than putting them on the requirement. Well, you can throw away what we've done and replace it. You can replace what builds policies and what returns them to the authorization service with one of your own. So if you are used to having arguments in the attributes and you want to keep them that way, basically you take those attributes and a policy name and shove them all together in one string separated by hyphens or whatever. And then inside your own policy resolver, your own policy provider, you can build a policy how you like on every single request. It could change from one moment to the next based on your whim. So that is authorization. Hopefully you no longer need to write authorize attributes. If you still feel what we have given you is not enough for your scenario, I would love to hear about it. Please file an issue on GitHub or drop me an email. So like I said, we have forward compatibility packages for data protection. We have cookie sharing, which basically replaces the old Katana-based cookie formats with the new ones. And that's how we sort of get an ASP.NET 4.5.2 apt to talk membership and authentication to core. Then there are a few miscellaneous things that we've done. All the encoders, HTML encoder, JavaScript encoder, XML encoder, blah, 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 they're all safe list based. They are no longer based on unsafe lists. So that means there is no need for anti-XSS anymore, if any of you use that. The encoders are in DI, and they can be injected into your DI source classes. CSRF protection can now be automatic. You can turn it so it appears on every single request and is checked on every single post. But we don't do that by default because it was a bit too much for folks to take. To be honest, you're so used to putting validate anti-forgery token based on your controllers that you know, this is just an option. If you want to use CSRF in JavaScript because you are still using cookie-based auth and you have not moved to bearer, which is not vulnerable to CSRF, you can actually access the CSRF token inside your view and write it out to a JavaScript variable so you don't have to parse the DOM and go for the form stuff or do the weird double drop cookie thing that Angular does. We have CORS middleware, so you no longer have to figure out how to write those horrible, horrible headers. And there's no difference between the debug and release buttons anymore. When we want to dump out the yellow screen of death, we check an environment variable. Because what used to happen was people would deploy debug web.configs or debug DLLs, and when things crashed, they would get full exception stacks, and nobody wants that in a live environment. So there is an environment variable called ASP.NET Core environment. If it's not there, we are going to assume that you are running in release mode. When you run within Visual Studio, we set it so that instance is running in debug mode. And that's how you control it now, rather than using web.config. Here's how we can turn on automatic CSRF validation. It's very exciting. And here's how we get the tokens and views. And secrets. Everything now is an environment variable, mostly. You can write your own secrets provider if you want to put things in like Azure Secret Store. No, Key Store. That's what it's called. And we've been looking at providing one of those for you. The reason we used environment variables is about 3 years ago, I decided it would be really funny to search GitHub for Azure credentials. There were an awful lot of them on GitHub. And the vast majority of them worked. People check secrets into GitHub. And we have decided to make your life a little bit more painful in order to make it a lot safer. Now, most hosting environments, be it AWS, be it Azure, be it the main third-party hosters, all allow you to set environment variables for your application pool. And that's where you put your secrets now and your settings, because you can't check environment variables into GitHub. There is a secret manager. It allows you to do all sorts of funky things within Visual Studio. It is there for your development use only. And we put those secrets well outside of your source directory, so you can't accidentally check them into GitHub. So, we are pretty much done. I have like 3 minutes left for questions, which I always enjoy because that means I'll get one, and then I can go get coffee. I would hope that I have covered what I promised to cover. What has changed in authentication, what has changed in data protection, how we have done away with the authorize attribute and changed the authorization stack, and the miscellaneous bits and pieces that we have changed just to make your life more difficult. So, the slides for this will be up on that website. They'll go on the VS Live website, I assume, but by the time I get back to the office, I'll drop them up there. The source code will be up on that, on that GitHub. And my own GitHub has the authorization lab. I strongly recommend you set aside an hour and a half and go through it. There are about 8 steps, and it will walk you through from adding authentication all the way through to writing policies with multiple handlers, changing your view, and then also doing resource-based authorization. So in a couple of minutes left, I can see people putting their bags on already because you want your coffee and your sticky buns. That's fine. I won't take offense. Does anyone have any questions? You all want your coffee. Hello. Right, him there. He's keeping you from your coffee. Yes, sir.
So we use VM snapshots in our production environment, so that we need to roll back.
Yes.
So you said that the keys with no more machine config, etc.
What would you do?
So how do we know when that expiry is going to happen if we're in the middle of deployment?
Okay. So the question is, because I believe this is being recorded, and this is where I actually prove that I do have a vague amount of presentation skills by repeating the question. The gentleman here has VMs, and they roll back their VMs in case anything goes horribly wrong. And the question is, how do I know when the keys expire? just to make sure that you're not overwriting things. So I would keep your keyring outside of your VMs in a database somewhere. But if you actually look at the files that are dropped, they are XML, and you can see the expiry date in them if you so wish, because the expiry date is not encrypted. But I would keep your keys everywhere. Keys should never get overwritten, because if they're in a database or if they're on the file system, they are individual rows or individual files. So overwriting doesn't occur. You might lose one that's just been created if you're doing a rollback, but like I say, keep them outside of the VM, and that should never occur, and then just keep backing up your keyring. But nothing's ever going to get overwritten, because keys are little individual discrete items if you've written your key repository properly. Does that make sense?
Yeah. So are you, like, for those of us that have hot spares and alternators spin up and spin down,
so if you
UNC share style?
So if you have hot spares, yes. So UNC is one option, and each key in a UNC share is just an individual file. So overwriting doesn't occur, and there's no locking, and that's how we prove scalability. If UNC shares work for you, that's absolutely great. It's built into the box. If you want to use SQL, you're going to have to write your own SQL provider right now, but give us a couple of weeks, and there'll probably be a slightly more generic one. But personally, I do it yourself, because you know your SQL environment and your SQL table names and how you want to lay them out yourself. Does anyone have any other questions, or are you off for your sticky buns? You're off for your coffee and sticky buns. Thank you very much for coming. I hope you have a great day.